Welcome to the lesson on Venn diagrams. Okay, so before we start the lesson, of course, we do a little warm-up on number sets. And we have a Venn diagram on the side to help maybe connect the idea of number sets to Venn diagrams early on. So the first question is, let U equal that set, and you can use a Venn diagram to help. A is a set of integers in U. So remember, integers, Z, they're whole numbers, in case you forgot. The set of integers is Z, whole numbers. B is a set of all rational numbers in U. So remember, rational numbers are Q. So have integer, numerator, and denominator. It can be expressed as a fraction with integer, numerator, and denominator. It's a bit hard to write that all in there, so I'll just do a quick summary. First question, list all the prime numbers contained in U. So remember, prime numbers have only two factors. So two factors only. In case you want to take a note of what prime numbers are again. So -4, it's not prime. -2/3. 1 is not prime because it only has one factor. Pi. 13 is a prime number. And 26.7, 69, 10 to the power of 23, none of those are prime. So we only have one answer for question A, and it's 13, because there's only one prime number in the universal set U. Then you're asked to list all the elements of A. So remember, A are the integers, whole numbers. So we can go from left to right. So -4, you would probably agree that's an integer. So -4, -2/3, it's not because it's a fraction. 1 is an integer because it's a whole number. Pi is not because it's not a whole number. 13 is an integer. 26.7 is not, it's got a decimal. 69 is a whole number. And 10 to the power of 33, sometimes people are weirded out by this, but all it means is 1 with 33 zeros after it. So it is a whole number, it's just a really big whole number, so it's still an integer. So we've listed all the integers so far in the universal set. Then in question C, list all the members of B. And remember, B is the rational numbers. So this is a bit more open. It's going to include all the integers that you listed in green above, plus some other numbers that are not irrational. So it's going to be kind of most of the set, to be honest. -4, -2/3 because it's a recurring decimal, like -0.6 recurring. 1, of course, is rational. Pi is irrational, so it's not going to be a rational number automatically. 13 is rational, 26.7 is rational, it's got a terminating decimal, 69 is rational, and 10 to the power of 33 is rational. So that's a pretty open set, and it includes all of the numbers in U, you might have noticed, except for pi, because pi is the only irrational number in that set. Last of all, question D, list all the members of the set A, upside down UB. That is the intersect of A and B. So by the intersect we mean this section here. So the intersect of A and B. So you've got to try to decide which numbers appear in both A and both B. So they have to appear in both sets. And you might have noticed that it happens to be all the green numbers, all the integers appear in both sets. So -4, you can basically list the numbers you had in question B. 69 and 10 to the 33. So we've listed all the intersect there. We can, if you want to try filling it in on the Venn diagram, so you can call the first circle A, call the second circle B. That's how we generally do it. And try to think, there's only one number that would exist outside of the union of A and B, and that would be the irrational number pi. So you can pop pi on the outside. In the center, we've got quite a lot of numbers. We've got all the green numbers because they are both integers and rational numbers. 1, 13, 69, 10 to the 33. I have to fill them in easily on here. Okay, are there any members of A that are not in B? The answer is no. So there's no section out here. But there are some that are part of B but not A, and they would be the fractions. For example, -2/3 and 26.7 are part of B, but they're not part of A. That's why they're not part of the intersect. So that's how you would fill in the Venn diagram. You might have noticed that it turns out that A is actually a subset of B. So technically the Venn diagram could be written like this, like was done in the previous warm-up, where you have B, the rational numbers on the outside, the universal set there, and you have A on the inside, because it is a proper subset. So that's another way that you could express the Venn diagram. But we'll just move on from there. So let's go on to question 2 from the warm-up. So question 2 from the warm-up says, let U equal positive integers less than 15. So notice it does not include 15. So that's not including 15. Sorry, this board's a bit weird, so the calibration at the top's a bit strange. X is multiples of 2. So for example, 2, 4, 6, 8, ... continues on infinitely, except for the fact that X would be part of the universe. So it's got to be less than 15. So if you wanted to, you could express them exactly. That might help. So the multiples of 2 that are less than 15 are 2, 4, 6, 8, 10, 12, 14. So we've listed all of X there. Y is the multiples of 3. Y has to also belong to the universal set. So the multiples of 3 that are less than 15 are 3, 6, 9, 12. Try to think, would you include 15? No, you wouldn't, because the universe is positive integers less than 15. So if it was including 15, it would say less than or including 15. So now we're asked, show in a Venn diagram the relationship between U, X, and Y. So I think in your textbook they put the U down here. Some other textbooks they put the U up here. So I'll just stick with what your textbook does. So the positive integers less than 15, remember that the universal set, if you want to also write that, that might help. We can, if it'll let me write it up here. No, it won't. Yep, it will. 1, 2, ... up to 14. So it's having trouble writing that. So maybe let's fill in the intersect first. It's a good idea to go from the center outwards. So what numbers happen to be both multiples of 3 and multiples of 2, and they're less than 15? So the answer to that would be 6, because see, you've got 6 in both of them. So 6, it goes into the intersect, and so does 12. So 6 and 12 are part of the intersect. I probably also need to label my sets. So let's label X, and let's label the other one Y. So we can probably easily fill in the remaining part of Y. So 6 and 12 already belongs to the intersect, so we've got to have 3 and 9 has to be in this section here. And similarly with X, we've got to fill in the other multiples of 2 that are not 6 and 12 from that list. So we've got 2, 4, 8, 10, 14. The last thing, a lot of people forget to do the outside part. So remember, the universe has got all the positive integers less than 15. So if it helps, just write them all out. Like for example, positive integers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Remember, not including 15. So from that list from the universe, what numbers haven't been included on the Venn diagram yet? And they would be, for example, the number 1. So you just put them somewhere around the outside of the union. 1, 5, 7, 11, and 13. So I could have put them up here, for example, instead as well. It doesn't really matter, so long as they're outside of the set, the 2 circles. So we've finished the Venn diagram, so we've finished question A. I think we have? Yes, we have. Righto, so question B, list the elements of X upside down, Y. So I've put in a reminder, that is the intersect. The intersect of X and Y. So the intersect, by that we mean, sorry, this is really badly calibrated. So by that we mean this section in the middle only. That will do. So list the elements of the intersect, and you can see from your Venn diagram, it's the ones I've put in green. So if you want, you can go 6, 12. If you want to practice doing your curly brackets too, you can throughout this warm-up. X, U, Y, that stands for the union. So by the union, we mean all of the circles coloured in. So I've got these Venn diagrams here just to help you visually work out what the union would be. The union is all the numbers that are inside the circles, not the ones that are outside the circles. So not the numbers 1, 5, 7, 11, 13. So you could go, for example, oh sorry, I should say, Lynn is here too, union. So we would start with 2, 3, 4, 6, because it does include the intersect still, 6, 8, 9, 10, 12, 14. If you want to practice doing your curly brackets, that's how you do those. So that's B finished. C, find the number of elements in the complement of X union Y. That is, find the number, like find N, X, U, Y dash. So if it helps, write out X, U, Y dash. What they're asking for is they're not asking what are the numbers outside of the two circles, they're just asking how many there are. So if it says find the N of something, you need to count it. So you might want to make a note, count how many are outside the two circles. So just to make it a bit easier, I'll list the set. You don't have to though, because all you have to do is count the numbers. I'm just listing it, so you've got it as a reference. So for us to count how many are in this set, there's 1, 2, 3, 4, 5. So there are 5 elements. So you can just write the number 5, that's fine. So there are 5 elements. So the answer to that one is 5. So let's quickly save that. And now let's get on to the lesson on Venn diagrams. So Venn diagrams, I'll just scroll down a little bit. Lesson 4. So something is a collection of numbers or objects considered as a whole group. You probably guessed already, it's a short word. Hopefully let me write it. It is a set. E.g. female students, dogs with black hair. The prime numbers, students who play sport, students who play an instrument. They're examples of sets, which you might have realised already. So now let's scroll down to Venn diagrams. So Venn diagrams is what we're dealing with now. So Venn diagram. The Venn diagram is made up of 2 or more overlapping circles, unless there is no intersect, in which case they don't overlap. It is often used in mathematics to show relationships between, probably guessed it, sets. So relationships between sets. Try relationships between sets that we'll have to do. Venn diagrams are useful for examining similarities and differences between sets. For example, we have the intersect. So I tend to remember always start with the inside and work outwards, unless that's not possible. So students who study both French and German, so we could call this set F and call this set G. Notice, remember, we use capital letters to label the sets. So the intersect would be, actually they said P and Q, so I'll do the same. So we always have to do whatever the question states, and because here it says P and Q, let's go P and Q. So P or Q, that would be. Outside here are the students who study German only. So the word only is important, you might want to put that there. The students who study German only. And outside here are the students who study French only. So that's a key word. Whereas in the centre, there's those students who study both French and German. On the outside here, students who study neither French or German. So that's all we have to take for that page. Now let's move on to some examples. So in a class of 30 students, 19 study physics, 17 study chemistry, and 15 study both. So remember, I tend to start with the inside and work outwards with these subjects. Complete the Venn diagram showing this information. So don't forget to label your universal set, which your textbook does down the bottom. Physics, maybe call it P, good idea, and chemistry, call it C. Make sure you use capital letters. So 15 study both. So we're not filling in like the names of the students or anything, we're just filling in how many students. So like for example, the number in P intersect chemistry is what we're filling in. So sometimes your Venn diagrams ask you to list the elements in the Venn diagram. Sometimes they'll be asking you to put in how many there are, like the number of elements. So there's 15 elements, 15 students in the centre who study both of these subjects. So the next thing to look at is, let's look at physics only. 19 study physics, but they don't say physics only. So if they say 19 study physics, that means this whole circle studies physics. So that 19 includes the 15 that are in the middle. So therefore try to think how many extra study physics only. It'd be 19 minus 15, so only 4 students study physics only. Next one is chemistry. 17 study chemistry in total, and they didn't insert the word only. So 17 is this whole circle for chemistry and includes the 15 in the middle. So that means there are 2 on the outside. A lot of people think they're finished now, but you've always got to double check. If they've given you the total, these 3 numbers have to add up to the total. If not, it means there's a number that has to go on the outside here. So let's see, what is 4 plus 15 plus 2? I think 4 plus 15 is 19. 19 plus 2 is 21. And so, but there's 30 in total. So how many are on the outside? There must be 30 minus 21 equals 9 students on the outside. You might just put a little arrow showing that you think you're working out, just for your own notes. You don't need to in the question, but for your own reference, you might want to just point out how you got that number 9. A lot of people will forget that number 9. Then we're asked to answer a number of questions relating to that. So, question B. Determine the probability that a randomly selected class member studies both subjects. So this is pretty nice. You've just got to make sure you're paying attention to what the question is asking. Both subjects, they just neatly intersect. So of course that is 15. And to relate it to probability, which is a topic we deal with a bit later, just scroll up so you can see more of the Venn diagram. If they just want to know how many students, then 15 is fine. But if they want to know the probability, then it's going to be, this one is a bit nicer, 15 out of the total number of students. So and that simplifies to a half. So there's a 1 in 2 chance that a student studies both subjects because it's 15 students out of 30. Let's see, physics but not chemistry. So physics but not chemistry is this number here, 4. So again, that's 4 students out of a total class of 30. And that simplifies because they're even numbers on the top and bottom to 2 over 15. So 2 over 15 is the probability. So this exercise you're about to do might not ask for the probability, but occasionally I'll try to link earlier topics to later topics because they're quite convenient in the real world. So interestingly, at least one of these subjects, so at least one of these subjects refers to the union, meaning like any of these, this or this. So at least one of the subjects would be, you'd have to start with by adding them up. 4, I think you did that already actually, plus 15 plus 2 equals 21. So the probability will be 21 out of 30. And they can both be divided by 3. So that's 7 out of 10 is your probability. Exactly one of the subjects. So exactly one of the subjects, it's kind of referring to either the 4 or the 2, like the little crescents. So it can't be both, so you can't include the 15. So just add 4 and 2, because that's how many study exactly one of the subjects. So 4 plus 2 is 6. So that's the answer. 4 plus 2 equals 6. So the probability is 6 over 30. And the top and bottom divides by 6, so that becomes 1/5. And you simplify that probability. And neither subject, so we worked it out already, it's the 9 down the bottom right corner. So neither subject, it will be 9 out of 30. Top and bottom again divides by 3, so that's 3/10. And physics only is the number 4. So it's a little crescent, like this kind of part here, that's got the number 4 in it. So physics only is 4 out of 30. Top and bottom are even, so it simplifies to 2/15. So that's if you're asked to also turn it into a probability. You put however many students there are over the total number of students. Let's move on to the next page, where we are asked to draw some Venn diagrams from scratch. So tips for drawing Venn diagrams: summarize your information on the side first, if possible. Don't forget the box around the sets, like this big thing. Don't also forget to write the U next to it. Unless the word only is used, like physics only or chemistry only, make no assumptions about the set. So if they don't say physics only, then they mean the whole circle of physics. If they say students who study chemistry, they mean the whole circle of chemistry, not the little crescents on the side. If they say chemistry only, they mean just the little crescent, like the moon-shaped crescent. Let's do this example. Draw a Venn diagram and answer the following questions. In a class of 50 students, so remember that's important, that's our total, 18 take chorus, 26 take band, and 2 take both chorus and band. So we've worked out the intersect is 2. That's important because we're going to work from 2 outwards. How many of the students in the class are not enrolled in either chorus or band? And we're told to draw a Venn diagram to do this. So don't forget your box, I can do that first. And don't forget to label it with your U. And because there's only 2 things, there's chorus and band, and there is an intersect because 2 take both, we can draw 2 intersecting circles. If there was no students that took both, we wouldn't draw an intersect, we just draw them like that. But in this case, there is 2 in the intersect. So we're going to fill in how many students are in the intersect first. There's 2 students who take both chorus and band. We're told that in total, 18 take chorus. So we're not told 18 take chorus only. If it was 18 take chorus only, it would be this. But 18 in total take chorus. So that means the whole circle. And I should have chorus and band as well. Chorus and band. So 18 minus 2 must have 16. So in total, there's 16 plus 2, 18 take chorus. And 26 take band. So you probably realize already. 26 take band. 2 plus 24 makes 26. And are we finished yet? No, we're not, because we need to add up those little totals to work out are there any on the outside here. 16 plus 2 plus 24. Try to think, 16 plus 2 is 18. 18 plus 20, this is how you can do it in your head quickly, is 34. And 34 plus 4 is 42. So the one that study neither will be the total number of students, which is 50, minus 42 equals 8. So this number out here is 8. You could put it here or here, it doesn't matter, so long as it's on the outside somewhere. So just draw it, of course. So I'm just going to put a little arrow. So I look back and remember how did I get that number 8. So the answer is 8. How many students studied either chorus or band? Don't forget to write your final answer. Sorry, neither chorus or band. I'm not enrolled in neither chorus or band, sorry, because of the word not. So we were correct, it's 8 students. So don't forget to write that at the end. Question 2. Question 2, let's scroll down a bit for that. In a school of 320 students, 85 students, let's see, 85 students are in the band, 200 students are on sports teams, and 60 participate in both activities. How many are involved in either band or sports? So in this case, they're kind of wanting you to work out the union, but that's a bit more clear after we draw the Venn diagram. So again, there's only 2 things. We've got, what do we have? Band and sports. So we can call it set B and set S. So I always start by doing my box around the outside first and drawing my U before I forget to do that. Are there any in the intersect? Let's see. 85 in the band, 200 are in sports, and 60 study both. So there is an intersect. So we can draw 2 intersecting circles. If they said no students studied both, it would be like this. But quite often there is an intersect. So let's start from the inside out. We start with the both. So there's 60 that study both. Try to fit that in there. 85 are in the band. They don't say the band only, so we don't put 85 here. Instead, we have to work out 85 minus 60. And 85 minus 60 would give you 25. And again, I've forgotten to write band and sports. So don't you forget to do that. Because 25 plus 60 is 85 students in the band. 200 in total are on sports teams. So 60 are on both. So 200 minus 60 is 140 are on sports teams. And again, we've got to work out, is there anything on the outside here? So work out your total and see if that adds up to 320 first of all. 25 plus 60 plus 140. Let's see, what does that add up to? You can go 140 plus 60 is 200. 200 plus 25 is 225. So no, that doesn't add up to 320. So the outside part will be 320. Sorry, 320. Just 1 second while I pause it to get it going again. Here we are back again after I paused it and closed and opened it again. This has been happening a bit sometimes, the pen's just decided to work. So 320 is the total, minus 225. So how many do we have around the outside? Try to think, 320 minus 225, that would give you 95, wouldn't it? Let's see, does that make sense? Yeah, because 225 plus 5 is 230. 230 plus 90 is 320. So 95 on the outside here. Mind you, we didn't even need to work that part out because all they want to know is how many are involved in either band or sport. So by that, they want the union. So the union is the three numbers inside the sets added together. So it would be, let's go back to here. So the union would be 25 plus 60 plus 140, which we worked out over here anyway, is 225 students is the answer to this one. And now let's move on to the last page in our notes for today. Last examples. Okay, 3. A veterinarian surveys 26 of his patrons. He discovers that 14 have dogs, 10 have cats, and 5 have fish. So this could be a Venn diagram with 3 overlapping circles potentially. 4 have dogs and cats, and so on. If no one has all 3 kinds of pets, how many patrons have none of these pets? So none have all 3, but we still need to draw 3 overlapping circles. And we can just have nothing in the center, because there still will be some overlap like here, here, and here. So we need to make sure that those little overlaps are drawn. So draw your box and your universal set. You want to label everything. So I'm going to do D for dogs here, and I'm going to do C for cats here, and F for fish down here. So we were told no one has all 3 kinds of pets. So there's nothing in this little center here. That's just completely empty. So you could put in 0, or you can just leave it blank if you want. If it helps you just to put a 0 in. But we can kind of work out from some of the information. But for example, if they have dogs and fish. So 3 have dogs and fish. So because there is nothing in the intersect, dogs and fish, here must be 3. 3 have dogs and fish. 4 have dogs and cats. So dogs and cats, we have a 4 here, because there's none that have all 3. So that's why the 4 goes directly there. And 1 has a cat and a fish. There's this one here, cat and a fish, so there's a number 1 there. And now we can work outwards from here. So 14 in total have dogs. So in the dog circle, we've already got 4 and 3. So 4 and 3, sorry, adds to 7. And if there's 14 in total, we must have 7 extra that have dogs only. 10 have cats. They haven't said cats only, so we've got to say the whole circle must add up to 10 for cats. So 4 plus 1 is 5. So to add up to 10, we must have 5 that have cats only. And let's see. And also we need to work out, we're told also, sorry, yeah, 5 have fish. So it's hard to sort of like keep track of it all. Sometimes you have to keep reading over the paragraph. 5 have fish. In the fish circle, there's already a 3 and a 1. So there's got to be 1 out here that have fish. And there's 26 patrons in total. So if you add all of these numbers up, maybe you want to do it on the bottom somewhere. 7 plus 4 plus 5 plus 3 plus 1 plus 1. see, 7 plus 4 is 11, 11 plus 5 is 16, 16 plus 3 is 19, plus another 1 and a 1 gives you 21. So the amount that are on the outside must be the total. 26 minus 21 equals 5. So we have 5 outside here. And we're asked how many patrons have none of these pets. So you can, don't forget to just write 5 patrons at the end. So that's an example of a slightly different one because we had 3 circles overlapping. And also on top of that, there was none in the intersect. So it's all about reading the information really, really carefully and reading over it again and again to make sure you've got the right info. Okay, last one, let's have a look. A guidance counsellor is planning schedules for 30 students. 16 students say they want to take French, 16 want to take Spanish, 11 want to take Latin, 5 say they want to take both French and Latin, and so on. 5 want only Latin, that's an interesting one, only Latin, so the little extra part for Latin that doesn't intersect at all needs to have 5, and 8 want only Spanish. So they're useful ones because you can fill them in immediately. Again, we've kind of got, there is a fair bit of overlap, so we're going to have to do 3 overlapping circles. If in doubt, just do overlap, and if it turns out there's no overlap at all, you can always do a different one afterwards. So universal set, that's what we've got to label. We've got to label the languages. I'm going to do French here, I'm going to choose to do Spanish here, and I'm going to choose to do Latin down here. So I think we're told that, let's see, are we told that what all 3 want? That's something to look for. 16 take French, 16 want to take Spanish and French, and so on. So we might not have been told, let's see, and of these, this is actually where it's done. So 5 say they want to study French and Latin, and of these, 3 wanted to take Spanish as well. So these 3 students want to take French and Latin, and they also want to take Spanish. So they've told us there, in a quite complicated way, that there's 3 in the middle. So that's a bit tricky to work out from the beginning. Now we look at where they want to take maybe onlys. So the onlys could be useful. Like 5 want only Latin, so that's easy. You can fill out the only sections out here. 8 want only Spanish. So they are not part of any intersects. So the word only is kind of useful. It means you can actually fill them in straight away. We want to know how many study French only, so that one's going to be blank for now. Now we can maybe look at who want to take kind of both. So 5 say they want to take both French and Latin. So French and Latin is kind of around here. And of those, 3 wanted to take Spanish as well. That tells us that in total, this crescent, whole crescent, has to be 5. So 3 is already in the middle, then 2 has to be on the side there. Let's see, are there any more that we can use at this point? Oh yes, we can work it out because we're told how many want to take Latin in total. 11 want to take Latin in total. And Latin we've got 2 plus 3 plus 5, that's 10. So there must be a 1 here if there's 11 in total in that circle. Now look at Spanish. We've got all 3 for Spanish, we're just missing 1. Let's check how many need to take Spanish in total. 16 want to take Spanish. So far we've got 8 plus 1 plus 3, so that's 12. So 4. For this circle to add up to 16, we must have a 4 that take French and Spanish only. Let's see. Are there any on the outside? I think they're assuming that all students say they want to take a language. So in this case, maybe we're assuming that all students want to take a language. So therefore, there's 30 students in total. So we want to know how many are here. How many want to study French only? So because all students seem to be taking a language course, there's no choice that they can take no languages. Then we can kind of add them all up. If you add them all up, like for example 4 plus 8 plus 3 plus 2 plus 1 plus 5, if you add all of those up, you will get 23. Let's check that. 4 plus 8 is 12, 12 plus 3 is 15, plus 2 is 17, 18 plus 5 is 23. So French only, I'll just make a little note of that. French only must be the total, which is 30 minus 23 equals 7. So let's put that in here now. So there must be, sorry, fix that up, there must be a 7 there. So 7 students. In a way, you've kind of worked it out down here, so you can just say this is the answer. And that's a little brief introduction to Venn diagrams.